holding the quality rod.
Okay, so let's say if we wanted to sketch y equals
Might never.
3x plus 2. Okay, so the first thing you want to do, you want to get 2 points. Okay, so what I normally do is just draw a table where you have your x and y equals 3x plus 2. Okay, so if you make x equal 0, which is usually the easiest one to start with, you have 3 times 0 plus 2, which is 2. Okay, so that gives you the ordered pair of 0, 2. When x is 0, y is 2. Okay, so let's pick another one. You can pick -1, 1. Doesn't really matter. When x is 1, that's 3 times 1 plus 2. 3 times 1 is 3, plus 2 is 5. Okay, so that gives you the ordered pair 1, 5. When x is 1, y is 5. Okay, so we'll call this example number 1. And we'll use this sheet here to graph it. Okay, so we'll use this for example 1. Okay, so we just have to find the points 0, 2 and 1, 5. Okay, so starting at 0, we go 1, 2, well, we go 1, 2 up. That's the point 0, 2. Trying to see if I can get it out of the glare. There we go. Okay, so that's 0, 2 and 1, 5. We go 1, and then we go up 5. 1, 2, 3, 4, 5. So that's the point 1, 5. And then from there, you just draw a line right through them. And you can use anything to draw your line through. It doesn't really matter. Okay, and that's actually your graph of y equals 3x plus 2. Okay, so any questions on that one? Yes.
In some of the homework problems,
Mhm.
it asks you the graph fraction. I was just wondering if there's another way to do that.
Well, first thing I would do is make x equals 0, and that would usually get rid of that one. But normally, whatever the denominator is, you'd want to make x equal that. So if you had 1/2 x minus 5, if you make x equals 2, then that 2 would cancel out the 2 in the denominator. Yeah. Yep, it's just the 1 minus 5. So that's usually the easiest way to go. All right. Any other questions? All right. Move these over here. Yeah. All right, so now we're going to graph our linear inequalities. Anyone still writing? Oh, bless you. All right. Okay, so graphing your linear inequalities. If you remember, your inequalities are just less than. Oops, clean that up a little bit. Just your less than, greater than, less than equal to, and greater than equal to. So that's less than or equal to. and greater than or equal to. Okay. Now, a linear inequality will look just like a linear function or a linear equation. The only difference is instead of equal, they just have one of those signs. Okay, so if you have 3x plus y is greater than 5, that's a linear inequality. If you have x plus y is less than 3, that's a linear inequality. Even if you have x is greater than or equal to 7y, that's a linear inequality. So all linear inequalities. Okay. Now the same way if you get an ordered pair to find out if a linear equation is true. So if you plug in x and then plug in the y, and if it's true, you know it's a solution. It's the same thing for linear inequalities. If you plug in your x and y, you just want to make sure it's true. So let's say, for example, determine if each ordered pair is a solution to the inequality, say 2x minus y is less than 6. We'll bring that up a little bit. Okay, so the first one, we'll let that be, clean up that a little bit. And say 5 and negative 1. And for problem B, we'll let it be 2 and 7. Clean up that a little bit better than what it is. There we go. Okay, so you have 5, negative 1, and the point 2, 7. Okay, so just like before, you just plug in your x and y and see if it's true. So for A, you have 5, negative 1. That means your x is equal to 5, and your y is equal to negative 1. So just plug it into that one and see if it works. Okay, so you have 2 times 5 minus negative 1 is less than 6. Okay, so you end up with 10 plus 1, so you end up with 11 is less than 6, which is false. Okay, so you know it's not a solution. So 5, negative 1, I'll put that underneath it, is not a solution. So we do the same thing with B. Let's move that up a little bit. Okay, so for B, we have 2, 7. That means that A is equal to 2, X is equal to 2, and Y is equal to 7. Kind of separate that a little bit. So if we plug them right on in, it's 2 times 2 minus 7 is less than 6. Okay, so 4 minus 7 is less than 6, which means negative 3 is less than 6, which is true. Okay, so that means that this is actually a solution to this one. Okay, so 2, 7 is a solution. All right, so any questions on that one? All All right, I'll leave that up there for a few more seconds. All right, so now we're going to actually graph a linear inequality. And it's just really one extra step above graphing a linear equation. All right, anyone's still writing? All right. Okay, so steps to graph. A linear inequality. Okay. Now your first step is you're going to replace the inequality with an equal sign. And graph that. Okay. Now, once you replace that inequality with an equal sign, there are two possibilities to that graph. If the inequality is less than or greater than, you're going to use a dotted line. But if it's less than or equal to or greater than or equal to, you'll use a solid line when you draw it. So if the inequality is less than or equal to or greater than or equal to, use a solid line. Okay, so it's just a little tweak to what we've been doing already. Okay. Now your second step is you're going to pick a test point from either side of the line. That is not on the actual boundary line itself. Step one gave you a boundary line. On the boundary line, from step one. Okay, and you're going to get that, and you're going to plug that test value into your original inequality. Okay. Now, if it's true, you're going to shade that section in. If it's false, you're going to leave it blank. It's true. Shade in that section. Uh-oh, sorry about that. If false, leave it unshaded. So let's say, for example, if you wanted to graph x plus y is less than 7. Okay, so your first step is you're going to replace that less than with an equal sign. And graph. Okay, so now we're going to graph x plus y equals 7. Okay, and again, I just draw the little table. You don't have to do the table if you don't want to. Okay, so you have x, you have y. So let's say if we make x equal 0, that's usually pretty easy. When x is equal to 0, you end up with 0 plus y equals 7, or just y equals 7. Okay, so that gives you the ordered pair 0, 7. Okay, so let's say when x is equal to 1. Like I said, you can pick any value you want. Okay, so that's going to give you 1 plus y equals 7. Subtract 1 from both sides. It's just y equals 6. Okay, so you end up when x equals 1, y is equal to 6. Gives you the ordered pair 1, 6. And actually, we'll call this example number 2 because we're going to put it on the graphing sheet. That up a little bit, and we'll call this example 2. Make sure I'm not blocking it. Okay, so we just have to plot 0, 7 and 1, 6. Okay, so move that up a little bit. Okay, so 0, 7, you have x is 0, y is 7, so you go up 7 places. Fill that in. And 1, 6, x is 1, y is 6, so you go up 6 spaces. Okay, now remember, because we use less than or greater than, that line is going to be dotted. So you're not going to just draw the arrow right through it. Okay, so you're just going to get that one, and I believe it's right through there. And I drew mine a little longer than it needed to be, but that's how it should look. And I didn't dot it, I always do that. Yeah, I always forget to dot it until after I've already drawn it, but I don't care how many times I remind myself, dot it, dot it, dot it. The minute I draw it, it's already there, so. There we go. All right, so we have our dotted graph. Okay. Now we go for our second step. We pick a test value on either side. It doesn't matter, me personally, if 0, 0 is available, I always pick that one just because it's easy. Okay, so remember your second step. And shade it in if it is true. Okay, so let me move that up a little bit. Okay, so like I said, just randomly I picked 0, 0. where your x is 0 and your y is equal to 0. Like I said, completely random. Okay, so if we pick the point 0, 0, we plug it in, x plus y is less than 7, just becomes 0 plus 0 is less than 7. So 0 is less than 7 is false. Okay, so we leave the section with 0, 0, which is right here. We'll leave that unshaded, which means that the other side is going to have to be true. So once one is left unshaded, you can pretty much assume that you're going to shade the other side. Yes?
How is 0 less than 7
Oh.
false? Thank you.
It's true. That's what I meant to put true. Just seeing if you were paying attention. That's all.
I got my calculator.
That's true. That's why I picked 0, 0, because I knew it would be true. But for some reason, I wrote false. All right. So you get that section and you shade it in. Okay. So once you shade in that section, you're pretty much set. The other section, you don't have to worry about checking, but you can if you want to, because only one section is going to be true. Yes?
So how do you select the point? Do you just do it to the left of the graph?
Oh, you can pick the left of the graph, the right of the graph. Me personally, I just like picking 0, 0 because it's just the easiest.
Once you pick that, how do you know? Like, you just plug in the numbers and decide?
Yep, you plug in the numbers into your original inequality. And if it comes in true, since that's 0, 0, we're going to shade in the side with 0, 0.
Okay. And
So,
what's the boundary line?
oh, that's where your y is equal to.
Okay.
When you replace the less than with equal to, that creates your boundary line. So this graph here is our boundary line. So you just can't pick anything right on that boundary line for your test value. It has to be either to the left, to the right, above it, below it. It just can't be right on it. All right. So any questions on that one? Yes.
What would be a scenario where you couldn't use 0, 0 as your test value?
That's if you have your boundary line goes right through 0, 0.
Okay.
So then you'd have to pick something else. And usually I pick like 1, 0 or something like that. So something like just above it where the number's not too big.
Okay.
That, that you can visually see that it will be less.
Exactly. Yeah. All right. So this one, I'll just mark this as x plus y is less than 7. Okay. So really the only difference between graphing an equation and graphing an inequality is that with an equation, you have one solution. If x plus y equals 7 and you know x is equal to 1, then you know y has to equal 6. With x plus y is less than 7, anything here would make that true. So if you picked negative 4, 2. If x is negative 4 and y is 2, negative 4 plus 2 is less than 7 because it's ended up being negative 2. So that's less than 7. If you pick 0, 4. If x is 0 and y is 4, 4 is less than 7. So anything in that shaded section will be true. So you literally have an infinite number of solutions. All right. Does that make sense? All right. All right. I'll leave that up for a second. Everyone's still writing. All right. So let's say if we try. And we want to graph x is, I'll say greater than, switch it up a little bit. X is greater than 2y. first step is we're going to graph x is equal to 2y. So the first thing we're going to do is replace greater than with our equal sign. Okay, so we have x equals 2y, and we're going to go ahead and draw our table. Again, you don't have to use the table if you don't want to, but just one of those things I like to do. Okay. Now on this one, when x is equal to 0, y is equal to, well, you just have 0 equals 2y. So in this case, y is just equal to 0. Make that a little bit longer. So you have 0 equals 2y. Divide both sides by 2. You end up with y equals 0. So you actually have 0, 0 as your first point. Okay, let's say x equals 2. And the only reason I didn't use 1 is because you divide both sides by 2, you end up with a fraction. So I just used 2, so you'll end up with 1. You could use 2 or 4, either one. Okay, so you have 2 equals 2y. Divide both sides by 2, you end up with y equals 1. Okay, so you have the point when x is equal to 2, y is equal to 1. Okay, so we can go ahead and graph that part. And we'll call this example number 3.